What inside in commercial aircraft? We look at all the components and how it's work. Let's jump into the video. For demonstration in this video, I use world's largest passenger aircraft, the Airbus A380. Let's start with some brief introduction of the aircraft. The weight of fully loaded aircraft is about 1,265,000 pounds, that equal to 165 elephants. The maximum speed of aircraft is about 1,185 km per hour. The maximum traveling range is 15,000 km. Let's jump into the technical details. At the tail cone of the aircraft, a small jet engine is placed. This is called APU. The APU stands for Auxiliary Power Unit. It provides additional source of electrical power. Usually electrical power is supplied to aircraft by the main engine generator. In the case of main engine generator failure, the APU acts as an electrical generator. Main function of the APU is to start the main engines of the aircraft. And it provides air conditioning to the cabin. The aircraft have two decks, main deck and upper deck. Usually, the cockpit are in the main deck. It can able to carry 868 passenger, 583 on main deck, 330 on upper deck. At the lower end of the aircraft, there is 4 waste tank is placed. Total capacity of the waste tank is about 2,096 liters. The waste tanks is connected to the lavatories and galleys of the aircraft. There is 8 water tanks is located at the center of the aircraft, 4 tanks on left wing side, and another 4 on right wing side. The total capacity of the water tank is about 2,270 liters. The moving parts of aircraft, such as doors, landing gears, flight controls, etc., they are heavier in size and weight, so they need more power to operate it. So the hydraulic system are used to operate the heavier parts of the aircraft. There is 3 hydraulic reservoir tanks, green, yellow and blue. The green reservoir for landing gears, normal brakes, engine 1 reverser, and yaw damper 1. The yellow reservoir tank used for nose wheel steering, alternate and parking brakes, cargo doors, engine 2 reverser, and yaw damper 2. And the blue tank used for emergency generator. The fuel tanks are located in the main wings and tail wings. The main wing tanks are separated in 6 parts. There is 2 fuel feeding tanks. The tail tanks are separated into 2. The total fuel capacity of the tank is 320,000 liters, or 82,000 gallons. That enough to fly around 17.4 hours. The cost of fully loaded fuel around $1,70,000, or 10.2 million Indian rupees. This is the Ram Air Turbine. It is a small wind turbine that is connected to a hydraulic pump or electrical generator. Ram Air Turbine are used only in an emergency, in case of the loss of both primary and auxiliary power sources. The Ram Air Turbine will act as an electrical generator. It will power vital systems, such as flight controls, linked hydraulics, and also flight critical instrumentation. The commercial aircraft can be capable of producing 5 to 70 kilowatt of electricity, it depending on the generator. Let's take a look into the aircraft nose landing gear. It can controlled by the nose wheel steering in the cockpit. It can rotates 90 degree on left and 90 degree on right. Let's see what inside the nose of an aircraft. There is 3 components is here. This is a weather radar. Weather radar is used for identifying the weather condition ahead the aircraft. The localizer antenna, it is used for landing aircraft at 0 visibility. It will give the guidance for maintaining the centerline of the runway. I already made a video about how an aircraft landing at 0 visibility. If you interested, click here to watch. The glide slope antenna, it is used for landing the aircraft at 0 visibility. The VHF antenna, it is communication antenna, it capable of transmitting and receiving signals in the VHF band from 118 to 156 MHz. The ADF antenna, ADF stand for Automatic Direction Finder. It is an aircraft navigation product that automatically calculates the relative bearing of the aircraft to the radio station. ELT antenna, ELT stand for Emergency Locator Transmitter. In the event of an aircraft accident, these devices are designed to transmit a distress signal on 121.5 and 243 MHz frequencies. Let's see the main part of the aircraft, the engine. Each engine generates 40.5 tons of thrust. It more than about 75,000 horsepower. The total thrust produced by the aircraft is 165 tons. The fan operates nearly 3,000 RPM, with tip speed at 1.5 times of the speed of sound. Fuel cost for flying the aircraft approximately $29,000 per hour. The engine titanium fan blades suck in over 1.25 tons of air at every second. Hints: do you know why most of the aircraft are painted on white in color? The main reason is to reflect sunlight and minimize both the heating and any potential damage.